Hello.
Hi.
How are you?
What'd you say?
I said
Sorry.
it's okay. I said how are you?
Good, how are you?
Good. Sorry. So like, darn it, you sent me the what is it, the worksheets twice. So I was like gonna feel overwhelmed, but luckily like it's duplicate. So like the stuff that you sent me is manageable. And yeah, what is it? Like, so you have to remind me that which you wanted to skip, and like, I'll like take your lead on what you don't need to see, and otherwise, I've looked at it thoroughly, and so I like have a game plan.
Okay.
Okay.
I'm just getting your text like right now.
Sorry, say that again.
I'm just getting your text right now.
Okay.
Did you want me to go on to that?
Yes, ma'am.
Okay, you want me to do that?
Yes, ma'am. Okay. Oh no. Wait, you still got to be on the phone though.
Hello.
Yo, you hung up on me.
Yeah, so you wanted me to go on Zoom?
Oh no, 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 not Zoom. The Helm site.
Oh, okay.
Okay, I'm in your room. No worries.
Okay.
It's okay. When did you get home?
3:30?
Okay. And why earlier today? I mean, it worked out well for me also. So, but why did you want to meet early today? Do you have like a bunch of things you have to do after this?
Yeah.
Okay. Work or fun?
What?
Work or fun?
Okay. So,
Okay.
well,
That's cool. All right. Let me know
uh,
when you're there.
can you like can you send me the link?
Ooh. Just Helm Tutors and then your usual like login.
Doing that. Is it helptutor.com?
Yeah.
Is it putting that like flash player type thing?
Like the Flash situation is done.
What?
The Flash situation is resolved. We've met since then.
Yeah, I know. I don't know why.
That's so strange.
Okay.
Okay.
Now I'm on it.
Okay.
I'm in now.
Okay. You're in the room?
Yeah.
Okay. Um, all right. So let me try and write, and you should be able to see it. Sorry. Oof. I'm like uh, pretty sleep deprived, and so like, yeah, like this is. I mean, I have like I drank like my third, fourth cup of coffee, so I have enough energy to like do well on this, so we're good. Sorry. And what is it? Yeah, hold on. Let me write you hello, and let's see if you see it.
Yeah.
Okay, cool. All right. So, which part did you not want to need to see, bud?
I believe it was the first one I sent you with the 9% tangent, like using that electrocutilla to find angles and sides of a right triangle.
Mm-hmm.
That I like know.
So the first page.
Yeah.
I mean the first chapter. But no, hold on. All right, that's good. But like just as a quick like kind of check on just one or two questions on that page, so that we can summarize. Like, let's say that like I have obviously like it goes without saying, but you could only do these trigonometric ratios on a right triangle, so the triangle must be right. Now, given that the triangle is right, let's say that like this is 3 and this is 4, and this is theta. How would you find theta in my example here?
But
Hmm.
and you could use tangent. Um, so
So tan theta is equal to 3 over 4, and then where to from there?
Okay, you can angle, you would have to be tan, you could be like tan inverse of 3/4.
Exactly. This statement is identical to writing theta is equal to tan inverse of 3 over 4. They're the same statement, but obviously, sorry, you want the what I'm writing just now. So right here, the bottom one, you want it when you want to find an angle, and obviously, like for 3 over 4, you need your calculator, blah blah blah, and that's that. Okay, good. I'm satisfied with your assessment that you don't need help on this first page. Okay, so let's go to the next one. Sorry. Obviously, you'd like decide on which tangent inverse or sine inverse or cosine inverse, depending on which sides are already, which is like if instead of the 3 and 4, the 3 4 5 makes a right triangle. If I had a 5 here, then it would be which inverse to find theta this time? Yeah, exactly. Beautiful, because you have the opposite from the perspective of theta. You have the opposite side and the hypotenuse, and so then you'd use sine inverse of um, sine inverse of 3/5. Exactly, that'd be theta. All right. Sorry. So I'm good with that, and so like on the bunch of questions that you have there, like your work is all good. And again, I read every one of them like in detail, including the questions, blah blah blah. And so, like you don't really. We could like kind of skip around as we go through 11 through 16, but I this is something that you already understand, obviously, from the work that you've displayed. But just very quickly, like to big picture summary is like so like it's all about angle of elevation and angle of depression, right? And so I like when I first was like teaching this or learning about it, actually like learned about it while I was teaching it, thought the angle of depression would be this angle right there, and the angle of elevation would be right here. Like so, let's say theta and then beta. So I thought beta was the angle of depression and theta is the angle of elevation. Theta as an angle of elevation makes perfect sense because, well, it's like an angle of elevation. You can see it. But like what kind of struck me as odd is that beta is not the angle of elevation. If theta here, sorry, the angle of depression. If theta here is the angle of elevation, the angle of depression is this angle right here, which has the same value as theta. Think back to geometry. So basically what I'm saying is angle of depression, angle of elevation are the same angle as far as their value. So this is angle of depression. Sorry. So stay away from that angle of depression. And this is angle of elevation. Okay. So why would they be the same? Think back to geometry. Why would they be the same?
Because of the, I forget what it's called,
Mm.
but kind of like given shape like that.
Yeah, you got it. No worries. Alternate interior angles. We've forgotten our geometry. No, it's okay. You don't need to know the names. You just need to know, like, you got it. Alternate interior angles. So by alternate interior angles, um, angle of elevation, angle of depression end up being the same. Okay, got it, got it. Now, other than that, like it's just about like reading the question carefully, blah blah blah, and drawing the situation, and then from there, like answering the question. Obviously, now I'm not saying a lot at this point. Now, so like 11 through 13, they're like pretty repetitive, and then from 14 to 16, I think they're all angle of depression questions. 15 and 16, like 15, you didn't have your drawing. 16, it looks like you haven't done, but I did read it. So 16 we can do together after you read it. But on 11 through 13, you decide if we need to go over any of them, or we could just skip whatever you want. Like I'm happy with, yeah. Okay, no problem. Yeah, because like 13 is like find theta, right? Like the rest of it is just like read the question, draw your triangle appropriately, label the sides that are given appropriately. Otherwise, it's the same set of questions in 11 through 13 as what you had done on the first page. And therefore, it's kind of very redundant. Now, all right, so I personally like I want to add 15 onto 16. So how about you read 15 since you didn't draw the situation? Your work is correct, but um, read it and then let's draw the situation and just make sure that we understand why you got to the equation you got to. Go ahead.
Okay, so in airplane flying from altitude of 8,900 feet over water.
Okay, pause. So if I was drawing a triangle, like what the 8,900 what feet, what would that represent?
The like it's the part where the vertical part
Yes,
comes up.
exactly. Exactly. You just said the keyword. I just needed to hear vertical. Exactly. It's the vertical from here's the water, here's the plane or whatever, right? Like blah blah blah. Okay. Okay. So this is 8,900 feet. Got it. Continue reading.
Um, the pilot stopped around clearing the water at 28-degree angle of depression.
Okay, got it. Now, so obviously, like my plane should be facing, or it doesn't have to face the other way. The angle of depression we said is like measured from the horizontal there, but it's like it's like this, and like so here's raft, whatever raft, and so this is the angle you're given right there. So that angle right there is 28 degrees. But um, I don't think you have your pen, but you should be able to draw also. It should be very clear that this here, right here, is also 28 by what we said on the previous page. So the angle of elevation is 28, although what you're given is the angle of depression. Got it. And so continue from there.
So if you're trying to find the horizontal distance from the airplane
Yep.
to the ground, then around like the tangent that's from the just be
Exactly. Like my 8,900 should be like moved closer to the to look like the vertical, whatever, blah blah blah. Okay, so 8,900 right here. I'll make it clearer. Obviously, from the triangle's perspective, and this is the triangle you're looking at. You're looking at the opposite, and then what you need is the adjacent side, and you're given the angle that relates those two, and exactly as you said. So that means 10 of 28 is equal to 8,900 over x. And so, um, what is the horizontal? So you're trying to solve for x. So how should I solve for x here? If we finish solving, go ahead. Hmm?
what do you mean? Okay, so when we do the
Yeah, we set it up, but we didn't finish solving. So how do I find x from this equation? Okay, but like, sure, you need your calculator. Real quick, I'll help. Like, so instead of making you guess what's on my mind, so write the 10 since it's like a fraction on the right side. Right, the left side is a fraction over one, and you could flip both of them because well, you want x in the numerator if you're trying to solve for x. So from an equation like this, an equivalent equation, and we did this last year in geometry, is to write 1 over tan of 28 is equal to x over 8,900. And so from here, multiply by 8,900 on both sides. These are algebra steps that I'm pretty sure that you know how to do. I'm like 100% sure that you know how to do, but I just wanted to make sure that you know. Anyway, check, make sure that you're in degree mode in your calculator, blah, blah, blah. Type this into your calculator and it'll tell you what x is. Okay, that's that. Okay, 16 is a verbose one, but read it and I'll ask you to pause and whatever, but go ahead.
Max is sitting in the stands at baseball stadium to catch the foul ball and starts to throw it.
Okay, sorry. So here's the baseball stand somewhere here, blah blah blah, and he throws the ball, and like the horizontal distance is what you're given. So this horizontal distance, that part like I don't need you to like articulate because well it said literally the horizontal distance was 61. And if I finish my triangle, like from max is right here, first base is right here. So which value are you given in 76? Yeah, sure. On the triangle, which part are you given? Exactly, exactly, exact word. Excellent. Okay, 76. Great. And you're looking for the angle of depression. So then you need to draw a horizontal up top here and call this theta. So that's what you're seeking. However, again, from what we have done on the previous 2 pages here, this is theta, the angle of elevation. So if you find the angle of elevation, then you're basically finding the angle of depression. And so what equation should I write? And then how do I find theta, which is the angle of depression, same as the angle of elevation from here? Beautiful, beautiful. You know your shit, so you're definitely not like texting in your math class. um, sorry, good job, excellent. Um, sorry, can you hear the people that are talking outside in the background? Yeah, it's like, dude, like you're standing next to each other. Why do you have to talk so loud? Anyway, really. Um, okay, so sorry. So like I'll summarize like the blanks that you filled in at the top. Like I'm pretty sure that you know them, but like like these terminals, angles, blah blah blah. Like they make sense on the coordinate axis. So you have to draw your coordinate axes. This is x. This is y. No. And so, like, like it's typical to draw the terminal angle somewhere here in the second quadrant, but like, it's terminal side. This is theta. The initial side is always the positive x-axis. Always initial side when you're measuring angles. And otherwise, if you go counterclockwise, which means the opposite of how a clock ticks, then you're positive. If you go clockwise, the way a clock rotates, then you're negative as an angle. But otherwise, other than the initial side, this is the terminal side, and yeah. So that's that, and I think that's everything that. And obviously, like we both know from like our work in geometry together that like a full rotation is 360, so that almost didn't need to be said. Sorry. And so like uh, I'll just quiz you on like a couple of my own questions on what is being communicated on the three boxes directly below the blanks. And so like 75 degrees shouldn't be trippy because like well like 45 degrees is like right there in the middle between the x and y axis. So 60 degrees is a little steeper than that. So 75 degrees is steeper than that. Unless you're given a protractor, you can't really say what it looks like exactly. So like, a guesstimation based on, how I went about like 45 blah, blah, blah is like, a point of reference, an angle of reference. Well, never mind. That's a different thing. Anyway, like you get it, you get it, you get it. Okay. Now, if I had said, sorry, draw me 200 and not 270, rather negative 300 degrees. Like, so talk to me. Beautiful. That's a great start. Uh huh. Yep. Is that right? Yes, you're right. Because like right now I'm traversing clockwise as you said. Like I'll draw an arrow and I have gone negative 180. By the time I come around here, I've gone negative 270. So I need to go a little bit more, which is I need to go 30 more clockwise. So like this would be negative 300 degrees. Now, the other thing that you needed to do was like find coterminal angles. So coterminal angles is like technically this negative 300 degrees, if we'd gone counterclockwise, would have been how many degrees? Yep, yep, exactly. Good way to reword it. Go ahead. Oh no, not positive 300, but rather like I want to end up in the same terminal side as negative 300, but by going counterclockwise. So what positive angle is the same as negative 300 degrees is what I'm asking. That's right. So like, or we could just use our visual. Like, so look at where we landed and going negative 300 degrees. If we had gone counterclockwise to get a positive one, this angle would have to be positive 60. And it's exactly as you said, negative 300 plus 360, which is 2 pi in radians, right? Like that gets us to 60. Alternatively, we could subtract 360 instead of adding it, and so that would have been like if we did this, if we went around and came back around to it, and how many degrees would that have been as a negative angle? Another coterminal angle to negative 300 is, well, other than 60, what else would have been a coterminal angle? Yeah, sure. I said a lot. Yeah, like so we found a coterminal angle to negative 300, and we said that that's 60. And we got there like by either our visual or by adding 360. So find me a negative coterminal angle to negative 300. Yeah, sure. Yeah, exactly, exactly. So you said add 360 once. I did that, and I got to 60. The other thing to do is subtract um, subtract 360 from it, and you get negative 660. And actually, I liked, I was as I was like strategizing on how to teach you this. Like my strategy was like less efficient than like what you did here. So your coterminal angles like method of adding and subtracting 360 like works really well. And obviously, like if your angle was given in radians, then you would add and subtract what amount? Exactly. Beautiful. Now, obviously, like in the coterminal angles, that's what's to come on the next page. But like it felt natural to talk about it here, so that's that. Now, radians and degrees. Sorry. So converting from radians to degrees and degrees to radians is fairly straightforward. First of all, as you wrote, 360 degrees is the same as 2 pi. That's why you just said add and subtract 2 pi if the angle is given as radians to find coterminal angles, as opposed to adding and subtracting 360, because 360 and 2 pi are the same. It's just one of them is in radians, the other is in degrees, right? Okay, cool. Now, so obviously, like, if I divide both sides by 2, then I get 180 degrees is equal to pi radians, and I really don't know, like, I guess, like, he had to start somewhere, your teacher had to start somewhere, and that's why they wrote that, but, like, that felt a little random to cite that 360 is 2 pi and 180 is pi, but, like, anyway, it needed to be said, perhaps. Okay, now, what I want is the formula to convert from degrees to radians. So degrees to radians versus, radians to degrees. So what's the formula for degrees to radians? Mm-hmm. So what? So sorry. So what you want is a radian. So you need radian equals. Go ahead. Don't look at your page. Yeah, exactly. So if you're given degrees, all you need to remember is two things. It's 180 over pi or pi over 180, which is the reciprocal. And yeah, exactly. Pi over 180 is a small number. 180 over pi is a big number. So if you're given radians, you're trying to get big. So you need to multiply by 180 over pi. If you're given degrees, you're trying to get small. So you want to multiply by pi over 180. So for radians, you take the degree measure and you multiply it by pi over 180. And like for radians, you take the to degrees. You want a degree measure as an output, so you multiply by you multiply the radians by um, pi over 180 over pi. Sorry, 180 over pi. Here's a small hint if you have trouble remembering them. It seems like you don't have trouble remembering them, so perhaps you don't need my hint. But the small hint is this, which is other than you're trying to get small, it's trying to get big. I don't know how helpful that was, but in degrees, you want something that doesn't have a pi in it. So this radian right there, it will have a pi in it. Therefore, you want the 180 over pi. You want the pi in the denominator because you need like a pi here to cancel whatever is the pi in the radians. So that might be a nice little helpful thing. But otherwise, I don't know how many of the the problems we need to do from 4 through 9. I can give you a little bit of a helpful thing, right? Like actually like maybe that earlier statement that like 360 is equal to 2 pi might be helpful. So from 360 is equal to 2 pi, we know 180 is pi. So how much is 90? Yeah, which is pi over 2. And then what about 45? Yep. What about 60? Mm-hmm. Yeah, you do. What portion of 180 is 60? Hmm. Sorry, say that again. Yeah. So if I'm trying to go from 180 to 60, what do I have to do to 180? Yeah, divided by 3. You said it. So 60 is pi over 3. And finally, yeah, sorry. Finally, 30 is what? Exactly. Now, this is just like maybe it's not tremendously. It is very helpful, like in the immediate, but like I'm kind of like laying foundations for the future too, because I imagine you're gonna build on this, blah blah blah. But now, sorry. So the reason why this is helpful is like first of all, you'd be able to readily answer 4, because it says what's 30 degrees without multiplying by pi over 180. So it's kind of a shortcut to avoid the formula. Have the formulas, but on some of the problems, you can avoid remembering the formulas is what I'm saying. Remember them, which I already see that you remember. But, and 4, you can very quickly answer it because 180 divided by 6 is 30. And so you just have to divide pi by 6. And so pi over 6. Okay. But equally importantly is like on a question like what's 150 degrees? From what I know, 150 degrees is 5 times 30. 30 is pi over 6. So that's 5 times pi over 6, which is known as 5 pi over 6. So again, you get there without the formula. Okay, and on something like, negative 220, obviously the answer has, and even in radians, has to be negative. So you wrote negative 11 pi over 9, so this trick is not very helpful, but it's helpful on 7. Because it's on 7, you need to go the other way, but it's asking you for 4 pi over 3. Well, that's the same as 4 times pi over 3. But we know pi over 3 is 180 over 3, so that's 60. So you have 4 times 60, because pi over 3 is 60 right there. So 4 times 60 is like 4 times 6, which is 24, I think, and then a 0, 240. So on some of them it would allow you, like on 9 also, like, right, like 9 says 7 pi over 4. So how could you use what we have on this page in this little trick to get there quicker without the formula?
I guess the 7 pi over 4.
Yeah, that's the same as 7 times pi over 4, but what's pi over 4? It's okay, right here.
So it's 180 pi.
Mm-hmm.
Then pi over 4 is 45.
Exactly. So excellent. Like I know you did that without looking at the page, but yeah, as we saw earlier, you just have to, yeah, trim these guys, right? So 7 times pi over 4 is 45. So you have 7 times 45 degrees. Got it. And maybe, that's a little bit of computation. How can we make that easier? Well, double 45 is 90. So quadruple 45 is 180. And you need 3 more, which is 135. So 180 plus 135. I don't know. You could like just multiply 745 also. I don't know if you're allowed calculators throughout. But anyway, this is helpful. Otherwise, on all of these questions at the bottom of this page, you could do the formulas instead of, listening to the strategy that I just gave. And that's perfectly well and good by me. Now, so on the next page, and now I'm on the next page, we have like made our life a lot easier because we kind of already talked about some of these items. So, um, like on 10, like you add and subtract 360. So when you add 360, you get the 425, blah, blah, blah. So just do your computation carefully, and that's all. And, like let's say that like, let's say you are given 900. I'm just like going the extra mile to guard us. Like, right? Like, because in 11, you're given 540. So you subtracted 360 and it worked. But what if the original number that you're given is 900? Well, if you add and subtract 360, right? When you add 360, you get what? Like, that's a lot. 1260. So that's by adding. So that's coterminal. But when you subtract 360, you won't get a negative answer. You'll get 540. So if you needed a negative answer, you subtract 360 again. So when you subtract 360 again, you get like something, a lot, 180. And then you subtract it again. So what I'm saying is like if you're given a big angle and you need to find one that's negative and one that's positive, and for the positive one, simple, just add 360 just as before. But for the negative one, if you don't get into negative territory by simply subtracting 360, just keep subtracting 360 again and again until you get into a negative one. And so that's that. And similarly, like, for adding and subtracting 2 pi, add 2 pi for the positive one and it will work out always. But if subtracting 2 pi doesn't work out, keep subtracting more 2 pi's and you'll eventually get into negative territory. But none of the questions seem to require you to do that. It's just me like, trying to cover our bases for the extra. Now, like in 13, I really liked that you recognized that the denominator is 9 and what's given. And so when you added and subtracted 2 pi, you wrote 18 pi over 9 because that is 2 pi. And so therefore you like set yourself up for success in ensuring that 2 pi was rewritten so as to have the same denominator. So that's great. Now, for 12, sorry. Yeah, like you just wrote 2 pi, and 2 pi is 36 pi over 18. You figured that out in an extra step, and that's perfectly fine. In fact, if I have any issue with your work, it's that you skip steps. So I don't have any complaint about, yeah, what you ended up doing in 12. Sorry. And can you read what's at the top of the reference angles situation?
The angle theta and standard form the reference angle is the positive acute angle run by the terminal side in the x-axis.
Mm-hmm. It's okay. It's okay. Yeah. So like the for refer They do say reference angle, right? Yeah. So yeah, reference angle, very important, and but it's not very hard, right? And so like let's say that we're doing 150, a simple example. First of all, that's positive, so you got to go counterclockwise, and then you end up at 150 right there. Got it. So then, like, you need to drop a perpendicular from the terminal side. We said the initial side is always the positive x. The terminal side is obviously the other ray, and that's that right there. And so from the terminal side, I'll put a highlighter on it. You just drop a perpendicular to the x-axis right there. And so then it's the acute angle that's formed by the x-axis and the terminal side. So that's right there. Obviously, the whole way would have been 180, half a turn, instead of a full turn. So if you went 150, then what you have left is 30. So in this case, the reference angle would have been 30. For 150, the reference angle I'm saying is 30 for 150. But that's kind of like my example. Since there are no examples provided, your work is good. But sorry. But let's we didn't do 16, so we'll do 16 together. But otherwise, let me give you my own like example. So let's say that you have like 540 negative 540 degrees. Well, first you should draw what that angle looks like, and so therefore figure out where the landing terminal side would be. What quadrant? But like also like relatively where in that quadrant. So talk to me about how I would have drawn negative 540. Yep, so, exactly. So that would have been a full. How much did I go right now? Uh huh. Okay, that's strange. Okay, my bad. It's okay. Are you on your iPad? Okay. Sorry. So how much did I go right now? Yeah, I went negative 360, so obviously I need to go more. So how much more do I need to do to go to 540? Yeah, exactly. But so that didn't work out because the reference angle would be 0. That's kind of like my made up example. So let's say negative 545. Then that would mean that I go negative 180 more from the negative 360. Right now I'm at negative 540. So I need to go 5 more. So then the terminal side would have been drawn right there. And so for the reference angle, I'll put a highlighter. So that's the terminal side. For the reference angle, we said you always drop a perpendicular to the x-axis. So I drop a perpendicular to the x-axis. That's this little tiny angle right there. How much would that be? Mm-hmm. Um, well, sorry. Yeah, I wait. Sorry. Like, maybe I confused. So we ended up 5 foot negative 540 had me land right there at this spot, and then I went an extra 5 up to get to the terminal side. So since the reference angle is that which is made with the x-axis, it would just be 5 degrees right there. Make sense? Yeah, my bad. If I made it confusing. Now, what about if I had positive 240 degrees? What would the reference angle be? This is the one item that I'm gonna labor, like other than what's to come in a second. Neither of them are hard, but yeah, like um, I just the stuff that we've done so far has been layups, and so I want to make sure that we hammer this so that you can have a very realistic shot at getting 100 on your quiz. Anyway, let's. What about 240? How would I do that? Yeah, exactly. Like I would have gone like 180, and then how much more from 180 do I need to go to 240? That's right. Exactly. Exactly. So then that's great. That makes it all easy because then, like, well, I'll highlight our terminal side. How would I find my reference angle?
Would it be 30?
The y30. And you always drop a perpendicular to the x, and it will be like this angle right there.
Um, or would it be 40?
Mm-hmm. Mm-hmm. This angle right here.
Yeah, but if it's in the third quadrant and that's 240 and the whole the quadrant 270.
Well, yeah, but you're forming it with with the y-axis. This would be 30. You already answered it. That might be why you're confused. So this angle is 60. So the reference angle is 60. Hmm. You always want the angle between the terminal side and the x-axis, and like the x-axis period. You don't care if it's on the positive x or on the negative x. Wherever your terminal side is, you want the angle between the terminal side and the x-axis in each instance. Um, okay, so I was already planning on doing one more, so I'll get to that one. So what about negative 245 degrees?
Sure, don't do that. That's in the third
Huh?
quadrant. On negative 245.
Hmm.
So that would put you in the second quadrant.
Yep.
And would the angle be 65?
Yes, exactly. Look, look. I drew my terminal side exactly. Very well done. And so once I draw my terminal side, I want this angle right there. Well, this all the way here would have been negative 180, and you needed to go like an extra like 65 to get to negative 240. So this angle is clearly 65, and the reference angle is never negative. So even if it's a negative angle that you're given, the reference angle would end up being a positive angle. All right. So finally, 16. So, and I'll do a couple of these. So for 16, it says 2 pi over 3. So, well, I liked what you did. First of all, this is 2 times pi over 3. Pi over 3 is a third of 180, so that's 60. So 2 times 60, which is 120. So you could either do it that way, using this clever trick, or you could do it by using the formula, the two formulas that we talked about. But it's useful until you like get the hang of radians. It's useful to translate it into degrees because, well, degrees are easier to visualize, right? And so you convert it into degrees, and you can, in the end, say what your answer is in radians anyway. So 120 would be like right here. So you draw your terminal side. So that's the terminal side. What is this reference angle right here?
Would that be 60?
Yeah, absolutely. Like from 120, you need 60 more to get to 180. Exactly. But then you have to report your answer in terms of radians. So what's 60 degrees in radians?
60 pi over 2.
Exactly. You already got the hang of that. Great. Now, what about if we are talking about, let's say, negative 225? Well, no, that wouldn't be how it would be given. Sorry. If we'd said, sorry, negative 5 pi over 4. Well, you talk. Go ahead.
So I'm just going to convert that to degrees.
Yep.
And that would be 225.
Exactly. Beautiful. Negative 225. Pi over 4 is 45. So negative 5 times 45. And then that's negative 225. Exactly. So now, so then, we have to go this much. That's 180. How much more beyond there do I have to go?
45.
Yeah, I agree. 45 more. Right there. That would put me right there. So the reference, so once again, since the terminal side is right there, the reference angle would be this angle right here. And how much would that be? Yeah, exactly. And we have to. It's got to be positive. We have to report in radians. We know 45 is like a quarter of 180, so that's pi over 4. Yeah. Okay. Cool. Need I say more about this reference angle situation? Okay. Cool. So for the next one, like there's the motivation that your teacher gave you and stuff. Like he's like the big picture, which is like if P is right here, and it has coordinates x comma y. Well, it means that like if we draw the ray and then the angle associated to it, like obviously the ray would be like, sorry, the ray would be like, darn it, the ray would be like that, right? And so then clearly this is y, and this is x, and we need to keep in mind that x is negative in that quadrant, blah blah blah. But like when you're dealing with actual numbers, it will show up. It will show up that x is negative and stuff. So you don't need to worry so much about that. Now this is theta, right? So for the reason why this reference angle is like so important is because even though the angle theta is right here, well, it wouldn't form a right triangle. There's no way to form a right triangle there. So you have to deal with the right triangle formed with the reference angle. So this is why the reference angle is so important. So for theta, like it's good to get you to the terminal side, but really you're dealing with this triangle right here. So then, sine of theta would be, first of all, by Pythagorean theorem, we know like you need to find out what the hypotenuse is. If we call it h, it's obvious that h is, first we write x squared plus y squared is equal to, well actually your teacher calls it r, so let's stay consistent. So and that's appropriate. So r is the distance from the origin to the point P. I'll highlight it in yellow. And sorry. So it's obvious from Pythagorean theorem that x squared plus y squared is equal to r squared. So then from there, taking the square root of both sides, it's clear that r is equal to the square root of x squared plus y squared. So that's how you get to r. You always just do the square root of x squared plus y squared. And what r helps you find is the hypotenuse of the right triangle formed by the reference angle. So you kind of use theta only to get to the terminal side, but in the end, what you're really dealing with is the reference angle. Anyway, like now that you've got these guys, it's kind of like the first page. You already know sine theta will have to be for looking at the reference triangle. So there's reference angle and then there's reference triangle. The reference triangle is the right triangle that involves the reference angle. So no wonder that it got the name reference triangle. So you're dealing with the reference triangle. And the reference triangle, obviously sine theta is equal to what? Looking at this triangle. Mm-hmm. Exactly. But you're like, I don't want to call it theta there because it's not the same value, but you're really working with this angle. You're pretending like theta is this angle. So you're looking at this right triangle. Go ahead. Mm-hmm. Exactly. And then cosine theta? Yeah, x over r. Great. And then tan theta? Yeah, you could either memorize them. The reason, obviously your teacher has already showed you the motivation of how these guys come about, the y over r's, the x over r's, blah, blah, blah. So I could have, like, not said it. I could have just been, like, memorize them. But instead of memorizing them, I'm kind of, like, reinforcing where your teacher did. Maybe he didn't explain it, like, the same way, blah, blah, blah. But, like, I just want to show you a way out of, like, having to memorize them. Now, like, the cosecant, secant, blah, blah, blah. Those are just reciprocals of these guys. So now that you've got these three, the others are easy. Cosecant theta is the reciprocal of sine, so that would just be r over y. Secant theta would be what? Exactly, it's a reciprocal of cosine. Secant with cosine, cosecant with sine, and that's kind of odd because you think cosine and cosecant would work together, but like hopefully I'm not confusing you in saying that. But cosecant is actually with sine, and it's secant that's with cosine. You probably already know this. I'm just being annoying and repeating myself. Now, cotangent theta would be what? Exactly, beautiful. So what I'm saying is that like once you get to sine theta, cosine theta, and tan theta, the other three are very easy. Just flip the right hand side, and that's how you're gonna. Sorry, that's how you're gonna get to the other three, right? Like so you know like it's all about really getting these main three. The others are trivial once you get to these three. Got it. Now, so then obviously I don't want to repeat the example that's on your page, so I want to give you my own example. So suppose that like um, suppose that p was the point -2 comma -5. Well, first thing is draw it and like figure out what quadrant it's at. So what quadrant is it on?
Would that be 15 negative 2 comma the third one?
Yeah, absolutely. Excellent. So -2 right here, let's say -5, let's say right here. So P is right here. First thing you should do is draw a segment to the origin. That way you can mark your R right there. But then even though theta is this, right? Even though the angle theta is that, what you're really dealing with is the reference angle. And what you really care about is the reference triangle. So the reference angle we know is formed by dropping a perpendicular to the x, and that's why kind of I was reinforcing that earlier. Anyway, that's -2 right there. So now that your reference triangle, I'll highlight it in yellow, is this reference triangle right there. Okay, that triangle, even though the sides are like negative, blah blah blah, like your triangle sides can't be negative, so you label it as like +2, and then +5, so you can get to R. So how would I find what R is now that I've got two sides of the triangle? Yep, exactly. Or you can memorize the formula, which is square root of x squared plus y squared. Either way, so R is, talk to me.
25 plus 4, which is coming out to the square root of 29.
Exactly, and that doesn't come out of the square root. Excellent. 5 squared. So that's just the square root of 29. Got it. So in the triangle, say the hypotenuse is square root of 29. And I don't think your teachers taught you this, but notice that like I abandoned for a second that we're in the third quadrant, meaning that like I abandoned like the fact that these are negative numbers when I label the sides of the triangle. I used positive numbers, 2 and 5. Technically, they are -2 or -5 because, well, we're in the third quadrant. X and Y are both negative in that quadrant. So you could just pretend like they're positive for the sides because they are. They're sides of a triangle. And then use this mnemonic. So it's a mnemonic that like every student in Algebra 2 trig is knows. And it's ASTC. And ASTC is all students take calculus. You're on the calculus course, so definitely applies to you. Another way to remember ASTC is another stupid trig chart. Anyway, either way you choose to memorize it, just remember ASTC. What that means is that like here, all of them, sine, cosine, and tangent, and therefore they're reciprocals. The other three, all of them are positive in case the angle that you're given, theta. And so like if you were given like 2 comma 5, if p was 2 comma 5, you would be in the first quadrant. So then when you say the sine, cosine, and tangent values, they would all be positive, and therefore the other three would also be positive. In the second quadrant, only sine and its reciprocal, cosecant, are positive, meaning that the other four are negative in the second quadrant if your reference triangle ends up in the second quadrant. So what do you think the T stands for in the third quadrant? And the meaning of that?
I'm honestly not sure.
It's okay. I'll help. I'll give you a hint. So in the fourth quadrant, only cosine and its reciprocal secant are positive. So if our triangle, our yellow triangle, from our point had ended up in the fourth quadrant, when you say the sine, cosine, blah, blah, blah values, then all of them would be negative except for cosine and secant. It's reciprocal. So then now, help me with the t. What do you think the t is telling us? Yes, those are the only ones that are positive in that quadrant. The other four are negative. Look at your answers. Like tangent, the tangent one is, oh no, but that's because your triangle for that point was in the second quadrant. Yeah, sure. So in the second quadrant, we said sine and its reciprocal cosecant are positive. So if you look at your answers, wait, what? 5 comma no. 5 comma negative 2 would have been in the fourth quadrant. My bad, my bad. 5 comma negative 2 would be in the fourth quadrant. So for the point that's in your example, P 5 comma negative 2, only cosine and secant would be positive. If I got too eager. So if you look at your answer, only cosine and secant are positive. The rest of them are negative. So does the ASTC mnemonic help now or make sense now?
Yeah.
Okay, cool. Otherwise, you know, now that you've got your triangle sides, 2, 5, and square root of 29, you can tell me all of the values. And the angle, obviously, is the reference angle right there. It's from its perspective, which is the same as our theta. Like, so you ignore theta and just work with that reference angle. Anyway, so sine of theta is going to be what for my example?
Y over R.
Which is?
Would be 5 over 29.
Yes, beautiful. Very well done. And then that's sine, so you automatically get cosecant for free. So cosecant theta would also be 5 over 20, square root of 29. And then what about tangent?
Would be 5 over 2.
Yep. And then therefore you also know cotangent. Sorry, I wrote cosecant incorrectly, but I'm sure you figured. Cosecant is a reciprocal of sine, so I should have written square root of 29 over 5. So square root of 29 over 5. And then cotangent theta is what?
2 over 5.
That's right. Now, what about, sorry, cosine theta?
Cosine,
Uh-huh.
then 29 over 2.
Sorry, for cosine. 2 over.
Oh, right, 2 over.
You got it, you got it. Like you're probably tired, as I am. What about sec theta?
Secant,
Mm-hmm.
then 29 over 2.
That's right, beautiful. Now notice that I'm taking you in my direction, meaning that like you know we have abandoned the negativeness and the positiveness of these guys, blah blah blah. But then by my mnemonic, the mnemonic I taught you, ASTC, another stupid trick chart, or all students take calculus. Either way you remember it, only tangent is positive in the third quadrant. Therefore, you have to put a negative sign, and sorry, tangent and cotangent. So you have to put a negative sign in front of your answers for all of the other ones. So for sine, it's really negative 5 over 29, and therefore for cosecant also. And for cosine, it's negative 2 over 29. So for secant, it's negative 29 over 2. Alternatively, you know, it seems like you already have a really good handle on like, you know, the y over r, the x over r, blah, blah, blah. So if you just go off of that, like, you know, for, like, we know, for tangent, for example, we know it's opposite over hypotenuse. So we know that that's 5 over 20, sorry, opposite over adjacent. So that would be -5 over -2 in my example. So the negatives would cancel. You'd end up with 5 over 2, blah, blah, blah. So you could go your direction or you could go my direction, which is like, my direction is like, use theta to get to the terminal side, drop a perpendicular to the x, use the reference angle to figure out your reference triangle, and on the triangle, label all the sides as positive, then write down the value of all 6, get the first 3, take the reciprocal for the other 3, and then use the ASTC mnemonic to decide which ones are negative, which ones are positive. Like, and it will always be like, after you write all 6 of them, only 2 of them will be positive, the other 4, whichever aren't positive in that quadrant, like the other 4 will be negative, and you just throw on your negative sign. Alternatively, you can go with your plan of like, well, if the y value on the point P is -2, then, well, when I do y over r, I have to write -2 over whatever the r value is. And so you could go in that direction also. I'm happy with whichever you do or whichever you prefer. You don't have to take my method. But yeah, that's everything, and like, I feel pretty satisfied about like how well prepared we are. Unless you have questions, I'm good.
I think I'm good.
Okay, cool. Do you have anything exciting that you're doing, or like not terribly exciting or worth sharing? Okay, yeah, mine neither. Like, so yeah, don't worry. Like, you're not missing out on anything I don't tell you. All right, love. Have a wonderful rest of your day. I hope it's not like too taxing, and I'll talk to you like on Friday. Okay?
You too. Thank you so
Okay.
much.
You're very welcome, dear. Have a good day.
You too.
Uh huh. Bye.